Good morning, student. So in the last class we have discussed about the electromagnetic induction and experiment to demonstrate the phenomena of electromagnetic induction, and about that experiment the laws must be studied known as Faraday's laws of electromagnetic induction and Lenz's law. Now today we will discuss about the self-induction. So what is meant by the self-induction? When an electric current is passed through an insulated conducting coil, it gives rise to magnetic field in the coil so that the coil itself behaves like a magnet. ಒಂದು ಕಾಯಿಲ್ನಲ್ಲಿ ನೀವು ಕರೆಂಟನ್ನು ಪಾಸ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತದಪ್ಪ ಅಂತಂದರೆ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಪ್ಪ ಅಂದ್ರೆ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ದ ಕಾಯಿಲ್ ಅದೇನು ಕಾಯಿಲ್ ಇರುತ್ತಲ್ಲ ಅದು ಕಾಯಿಲ್ ಏನಂತ ತಂತ ಆ್ಯಕ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತದೆ, ಇಟ್ ಲೈಕ್ ಆಸ್ ಎ ಮ್ಯಾಗ್ನೆಟ್. ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ ದ current in the coil is linked with the coil itself. Okay. Now, as the strength of the current in the coil is changed, the flux linked with the coil also changes. Under such circumstances, an EMF is induced. ಅದೇ ಸಮಯಕ್ಕೆ ಏನಾಗ್ತದಪ್ಪ ಅಂದರೆ EMF, electromotive force induced in the coil too. So, such EMF is called a self-induced EMF, and that phenomena is called as self-induction. So this is the experiment to know the self-induction. So here you are seeing a conducting coil is there. Okay, the coil, the two ends of the coil, one end is connected to the negative of the battery eliminator, and another end of the coil is connected to a rheostat, and from the another end of the rheostat is connected to the key, and from the key it is connected to a positive terminal of the battery. When switch is on, so what happens? The current flowing through the coil. So what happens when the current flowing through the coil? So the coil, around that coil, what happens? The magnetic flux as shown in this figure. The dot line shows the magnetic flux. They are linked to the coil. So what happens? The current is induced, so EMF is also induces. If the number of turns of the coil is n and the flux linked with each turn is phi, then the total flux linked through the coil is equal to n phi. In this case, the total flux linked with the coil is directly proportional to the current I flowing through the coil. That is, n is directly proportional to, or n phi is directly proportional to I. Remove the proportionality symbol, then you got equal to some constant, that is L. So n phi is equal to L into I, where L is the constant of proportionality and is called as self-inductance of a coil. So rearrange to that one, L is equal to n phi divided by I. So therefore the self-inductance L is a measure of the flux linked with coil per unit current. The self-inductance L of a coil depends upon, ಈಗ ಅದು ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್ಸ್ ಏನಪ್ಪ ಅಂದರೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ, ದ ಸೈಜ್ ಆ್ಯಂಡ್ ಸೇಪ್ ಆಫ್ ದಿ ಕಾಯಿಲ್ ಆ್ಯಂಡ್ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ಇನ್ ದ ಕಾಯಿಲ್, ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದ ಮೀಡಿಯಮ್ ವಿತಿನ್ ದ ಕಾಯಿಲ್ ಇನ್ ವಿಚ್ ದ ಫ್ಲಕ್ಸ್ ಎಕ್ಸಿಸ್ಟ್. ಸೆಲ್ಫ್ ಇಂಡಕ್ಟನ್ಸ್ ಎಲ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದಿ ಕರೆಂಟ್. ನಾವು ಡಿಫ್ರೆನ್ಷಿಯೇಟಿಂಗ್ ದಿ ಅಬವ್ ಈಕ್ವೇಷನ್, ದಟ್ ಈಸ್ ಎನ್ ಫೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಲ್ ಐ, ಅವಾಗ ಏನಾಗುತ್ತೆ ಎನ್ ಡಿ ಫೈ ಅಪಾನ್ ಡಿ ಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಲ್ ಡಿ ಐ ಅಪಾನ್ ಡಿ ಟಿ. ಅಲ್ಲಿ ಯಾವ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡಿದ್ದೀರಾ. ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಸೆಲ್ಫ್ ಇಂಡಕ್ಷನ್, ಫ್ಯಾರಡೇಸ್ ಆ್ಯಂಡ್ ಲೆಂಜಸ್ ಲಾ ಹೋಲ್ಡ್ಸ್ ಗುಡ್. ಹೆನ್ಸ್ ಸೆಲ್ಫ್ ಇಂಡ್ಯೂಸ್ಡ್ ಇ ಎಮ್ ಎಫ್ ಇನ್ ದ ಕಾಯಿಲ್ ಈಸ್ ಇ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಎನ್ ಡಿ ಫೈ ಅಪಾನ್ ಡಿ ಟಿ. ಸೆಲ್ಫ್ ಇಂಡ್ಯೂಸ್ಡ್ ಇ ಎಮ್ ಎಫ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಬ್ಯಾಕ್ ಇ ಎಮ್ ಎಫ್. Now from the above equation, E is equal to minus L di upon dt, or L is equal to minus E divided by di upon dt. The self-induced EMF produced per unit rate of change of current in the circuits called self-inductance of the circuit. The unit of inductance must be, it is Henry or volt second per ampere. This is the unit of self-inductance. I hope all of you know about the phenomena of self-inductance. So you are see here some multiple choice questions are there. That is, the unit of inductance is, answer Henry, volt second per ampere, Weber per ampere, all of these. So the answer is all of these. Then the second question must be it is inductance has the dimensions of flux per current, flux per length, voltage square per current. None of these. The answer is flux per current. The next, which of the following is not a unit of inductance? Henry, coulomb per volt ampere, volt second per ampere, all of the above. That is coulomb per volt ampere. In case of an inductance, current is proportional to magnetic field. So which of the following is unit of inductance? All of you know that is Henry. The property of coil by which the current EMF is induced, counter EMF is induced in it when the current through the coil changes is known as self-inductance. See, these are the some MCQs on that topic, that is self-inductance. In the next class, we are discussed about the mutual inductance. Thank you.